Now, we've spoken about students' t-test, and everything really follows from that. If you understand how that works, how the central limit theorem works, how we're just converting everything to so many units of standard error, and what the area under the curve represents, you really understand most of statistical analysis. Now, students' t-test and all the t-tests really for comparing the means of two groups, but sometimes we want to compare the means of more than two groups, and that is when we have ANOVA. The most common one is called one-way ANOVA. The one-way refers to the fact that we are only dealing with one factor. So imagine we're just looking at comparing the means of white cell counts between 4 or 5 groups of participants. So it's just the white cell count. That's the only thing we're looking at. That is just one factor. And it also has some levels to it. That just really refers to how many groups we are. So if it's a 4 group, it's really a 4-level one-way ANOVA if we look at that. Now, t-test, remember, we are comparing the means of 2 groups, but really here with ANOVA, 3 or more groups we are comparing to each other. Now, all the assumptions we spoke about when we spoke about students' t-test has to be met. The ANOVA is still a parametric test, so we have to have those same assumptions. Most notably, the data points must come from, for any variable, must come from a variable that has a normal distribution in the patient or in the population. The actual data point values, they must be from numerical type and they must be a continuous data type. We also have to have roughly equal variances between the values in each group. So if we work out the variance or standard deviation for each individual group, they've got to be roughly the same. And also these participants really have to be independent. So we can't be dealing with monozygotic triplets, for instance, as an example. Now, what the ANOVA does, it only determines that there's a difference between the groups. It doesn't highlight one group over any of the other groups or 2 groups over any of the other groups. It cannot do that. It's only going to tell you that there's some fundamental difference between the groups, but there's no individual group analysis that goes on. Now, it uses what we call the F distribution. We haven't spoken about the F distribution before, but it's a distribution just as any other. Doesn't look normally distributed, though. It has this positive skew, so it's got this tail going out towards the right, and it is shaped by the degrees of freedom, just like the t-test, the t distribution, I should say, and it has a mean of around 1. We're going to do exactly the same thing, though. There's going to be some critical F values. So many standard errors away from the mean would represent an area under the curve of 0.05, and the differences between all of those groups is going to be converted to an F value, and that F value is going to fall either side of this critical value. Everything would be the same. Here you see a beautiful example of random variables taken from, I think it was about 10,000 random variables taken from an F distribution, and you can beautifully see the mean is around 1, but there is this tail that goes off to the right. There's quite a bit of skewness to the F distribution. So what the ANOVA test really does, it compares the intergroup, the within-group variability to the between-group variability. And if it finds that the between-group variability is much bigger than the intergroup variability, the variability of the data values within each group, then it really tends towards an F value that'll be right far away from the critical value that will have statistical significance in some way. It's kind of the rule of thumb. Now, there are really many ANOVAs. You can well imagine from what I've discussed now how many groups there are, how many values, different groups there are, how they interact with each other, how many factors we are dealing with. There's a lot of different types of ANOVA. In essence, though, we are comparing the means of more than 2 groups.